Hi folks, hello from the Dinosaur Cave. We are going to be doing today our last Flux developer tutorial, meaning that we're bringing up a Flux cluster. Today we're doing the last cloud, so surely last but not least, Google Cloud, where we are going to deploy Flux framework with Terraform. So let's get started. I'm going to share my screen. What you're looking at now is the Flux tutorials repository. This is at the Converge Computing GitHub organization /Flux tutorials. I'll make this a little bit bigger so you can see it. Now within here, we go into tutorial, then we go into Google. Now, to kind of step back and remind you, for each of these tutorials, we want to take an approach where we use the same set of tools to build and deploy. So for building, we're using Packer, and for deploying, we're using Terraform. So in Google Cloud, if you go into build images, you'll see similar logic to what you've seen before. So the build.shell, this is actually the script that's going to be installing Flux, configuring. Now you'll notice the difference here is that we're using Rocky Linux. The reason we're using Rocky Linux is this is what is recommended in Google's best practices guide, at least at the time that we made this for this image. And this is basically going to install Flux, Singularity, and Auras. This is done via this HCL file that we will look at here. Can I make this bigger? Oh, I can. So this will look familiar. There's a project ID, there are label, there are tags. It's done with SSH. Now, the difference between this Packer build and some of the other ones is that this has an added ability that it's actually formatting the date. So you don't have to make a unique name. I should probably add that to the other ones too, although I haven't yet. Let's see. Now, this is actually really this right here took me a really long time to figure out because there's something called a communicator, and this is basically how you communicate with your builder on your cloud or wherever it happens to be running. I had assumed that I needed, SSH or one of the kind of standard communicators. I actually don't. The answer was actually to use none, and that when I did that, that's when it worked. So here's metadata. These are details that aren't important. And so basically, we're just using this configuration here that is going to run that script. It's going to run that script. It's going to build the image. It's going to show up in your console, and that's it. So I already did that. We're not going to do that again. So after you build to step back, you're going to have to do this for your project because, we're not providing images for you. So the first thing you do is you'd clone. You go into build images. Same make file here that we've had in other places. You can actually just type make, and it's going to do Packer init, Packer format, Packer validate, and then it's going to do Packer build. Now, in Terraform, we're going to export our Google project. So our project is called LNL Flux, and the main variables are actually in basic.tf vars as opposed to main. Just to give you a quick kind of summary of the design, in main.terraform, we're actually going to be referencing a module that's provided here. So this is base. So the main orchestration logic is in this set of base, actually modules and compute. This is refactored from the Google scientific examples that does have a Flux base. However, that Flux base has basically separate modules for, I think, like the login node and a worker node and a manager. I prefer just to have one simple, because Flux can basically look the same on all of the nodes and we don't need these special nodes. I refactored that just to be one, and I also made it installed via just one script. So if you're interested in the Terraform logic for how that works, you'll want to look in the base modules. If you're not, don't worry, no problem. If you're not, all you have to do is open basic.tf vars, and this is where you're going to customize stuff. So the main stuff that you're probably interested in is the machine type. So I currently have this set to something small, although for experiments, we were using size 112. Remember, these are vCPU. There are 2 vCPU per one actual CPU. This is if you would want GPUs. Compact mode, I've never been able to get compact mode for greater than 10 instances, but of course that's subject to change. This is the number, so we're only going to be creating 2 pretty small instances for this demo. The boot script is pretty important because this is what is going to do the final configuration of Flux. So here's like the independent minister privilege file. Here's the broker.toml that all of the nodes can see, so they know how to bootstrap and connect. And you should not need to basically edit. And then here's our favorite friend systemd, that configuration file. So you shouldn't need to edit any of this. Oh, and the last little detail here that makes Google Cloud different from the others is that it's going to actually bring up an NFS shared file system. And you'll see that when I log in, it's going to create my home directory from that. So those mounts. And I also will say that was developed by Ward Harold. Ward is awesome. I had worked with him since like 2017, I think. Okay, so let's run this, shall we? So we are going, let me just make sure we have the small instance type. Yep. So we're going to type make. Hopefully I didn't forget to do anything. It's checking stuff. It's looking for this thing, Terraform validate. It's going to say, do you really want to do this? And I'm going to say, yes, I really do want to do that. So this is going to come up. So let's see. Azure comes up in about a little over a minute, about 1 minute and 10 seconds. Amazon comes up in about, well, a little over 3 minutes, maybe like 3 minutes and 20 seconds. I don't remember this exact time. I think it's 2 minutes and something, but we are probably going to see that. So let's see. What can I show you while we're waiting? It's creating the firewall rules. So here's foundation.tf. This is what's creating our networking. This can be tweaked more. So for example, I have an exposed setting the MTU. I think that means maximum transmission unit. That would be set in here very easily. I will note that the default MTU, which is like 1450, I think, as opposed to, booting it up to like 8,900 and something. I had thought it would make a bigger difference, but I ran 2 sets of experiments, one with boosted MTU and then one with normal. And it had a very trivial difference, at least for lamps. Now, I will also say that Google uses tier 1 premium networking, which is basically Ethernet. And then when you add on the tier 1, you get a boost to your bandwidth. I will also say that Google is releasing, I think, a bunch of products this year that will help the HPC user community. I don't have details beyond that, but I think they're coming. So keep your eyes open and your ears open. But for the time being, this is the current deployment that we have. The networking will be improved, I'm sure. So let's see. We are creating our instances. And we're done. So that wasn't too slow. I think it was a couple minutes because I felt like I was talking for a pretty long time. So now we need the gcloud command. Woo, this is bright. Does anyone else feel like they go out onto like a pool deck when they open some of these cloud consoles? It's blinded by the light. So we're going to go to compute engine. And now, so here's our 2 little instances. So this is the lead broker. That's the second one. Here's the NFS. This is the shared file system. So what I usually like to do is just view the gcloud command. Gcloud is a tool that you can install locally to very easily interact with Google Cloud. I will say that I think Google Cloud has the best tooling. Like when you install drivers, when you use gcloud, like it tends to work really well. I don't find like a lot of bugs, for example. It's okay. This is saying okay. So here's what I kind of anticipated. It's creating this home directory. So systemctl status Flux service. I don't know if I need to do sudo for that. Okay, we're running. Flux resource list. Haha. And that's kind of it. So let me just tell you what you're seeing. So when you do Flux resource list, this is saying like Flux, show me the resources that I have. So we see that we have 2 nodes. We see that we have 16 cores. Remember that the instance type was -16, but that means that each of them only has 8 actual cores. That's why the total is just 16. Now we only have Flux 1 and 2 online. The reason is because in order to enable this kind of Fox elasticity, FAUX, we tell Flux that it has a lot more broker children, than it actually does. And that's really cool because these nodes don't exist, but Flux just thinks they're down. So if we were to bring up another node, whether that's in Kubernetes or it's on bare metal here, and then have it bootstrap, which is basically just having it start and like point at where the lead broker is running, Flux would just see the notice coming up. And that's really cool. That's how we've been able to kind of emulate elasticity. So let's run a quick command n to hostname. Ta-da! Magic. Alrighty, so that is the developer environment for Google Cloud. That's probably all I will show you. I will show you how to destroy it. So we'll do make destroy, and it's gonna, so the reason that you're seeing some custom logic, if you just use Terraform, because of the way that the networking is created, sometimes I've found that there seems to be some kind of race condition in how things are cleaned up, in that it will say, oh, I can't delete this subnet because this other thing exists. And it's kind of, it became problematic enough that I said, you know what? I am just going to issue these commands like myself. And so what I do first is I delete the NFS instance, and there's only going to be one of those. And so that's this command. And then I issue the gcloud compute instances delete command like this. That's what you see here for quiet. And then after that, I do make destroy, which, well, I do the Terraform, actually, Terraform destroy, to bring down the remaining resources so that you can't have this race condition between basically like the instances needing the networking, or the instances using the networking setup, and then the networking setup being cleaned up, which seems to happen based on the Terraform configs and the modules that Google has at the same time. So these will clean up, and that's basically it. So thank you for watching today. This is the Flux development environment for Google Cloud. We are finally next going to go into running some Flux commands on a cluster, which I feel like I should have done earlier, but that's okay. I wanted to be comprehensive, and that's what we've done here. So thanks for watching today, and I will see you later. Bye.